A player kicks a football from the ground level with a velocity of 27 meters per second at an angle of 30 degrees above the horizontal. This question is asking for 3 times the hang time, the distance the ball travels, and its maximum height. And so here, this is where the ball starts. It goes through the air. We're going to choose this line because it's at 30 degrees. This is the maximum height. It's still in the air, and then it hits the ground. So it's asking the distance from here to here, the maximum height, and how long does the ball stay in the air. So we're given 2 things. The velocity, the initial velocity at 27 meters per second, and the angle of 30 degrees. So here the diagram, this purple line or the purple arrow shows the angle the football is kicked, and what we need to know is the velocity in the x direction, and we need the velocity in the y direction. And so in the y direction, we're going to use sine, so the initial velocity times the sine of theta. So it's 27 meters per second times sine of 30, and we're given an answer of 13 meters per second. So the initial velocity in the y direction is 13.5 meters per second. And in the x direction, we use the cosine, and so we use 27 meters per second times a cosine of 30 degrees. And if you plug that into your calculator, it's quite a long number, but because we have 3 significant figures right here, 2, the 7, and the 0, our answer has 3 significant figures, 23.4 meters per second. And so the first question asks for the hang time. And so what we're going to do is use this equation y equals Vy, the initial velocity in the y direction times the time, plus a half g, which is negative 9.8 meters per second squared, t squared. Okay, and so we know it's going to, y will be at 0 right here. So the time, so we were starting with 0 level right here and going to 0 right there. So what we're going to do is rearrange the equation. So we're going to bring the Vyt over onto the onto the left side of the 0 or of the equal sign. Sorry. And so we got negative Vyt equals a half gt squared. And then the next thing we're going to do is move the 2 here from the right side and move it to the left side. So we've got negative 2 Vyt equals gt squared. And the next thing we're going to do is move the g from the right side to the left side. So we're going to divide each side by g. So our right side is t squared, and you can see there's the left side. And then the final thing, we want the t's, because we're looking for the hang time, the time. So we're going to bring this t right here over, or we're going to divide the left side by t. So therefore, if we divide the left side by t, we need to divide the right side by t. So that's why we've got t squared over t. So so what we're going to do we're going to get rid of this t, and if we reduce this t, then we need to get rid of one of the t's on the top. So we got t all by itself. So our final equation equals t equals negative 2 Vy all over g. And then if we put in our numbers, we got negative 2 times the velocity in the y direction over negative 9.8. And then we plug that into our calculator. It gets a very long number, but we only use 3 significant figures, is because we got 13.5 is 3 significant figures. And then how do you know that we have the right answers here? So just to double check, what I've done right here is this meters per second right there is this one, and this meters per second square, when you're doing division, you got to I guess rotate them, put the second square on the top and the meters on the bottom. So we'll do the meters cancel out, and then what happens is this second cancel out with one of those seconds. So our final answer, we left with seconds, so we got the right equation there. So the hang time, the amount of time the ball stays in the air, is 2.76 seconds. And so our second question is the distance. How far does it go from here all the way down to there? So we're just going to use x for that distance equals the velocity in the x direction times the time that was in the air, and the time was 2.76 seconds, and the velocity in the x direction we calculated earlier is 23.4 meters per second. So what we do is we put in those numbers, and then what we find is when we put into account a very, very long number, but because we have 3 significant figures here and 3 there, our final answer has to have 364.4 meters. And if we cancel this seconds with that seconds, you notice we're left with meters, so we have the right equation. Now let's find the maximum height the football goes. That's the height from the ground to the maximum height the ball goes into the air. So we know the ball is the total time it's in the air is 2.7 seconds or 2.76 seconds. And so what we need to do, so that's the time it goes from here all the way across there. But the maximum height is at the halfway point, and that is 1.38 seconds. And so we want to find the height, which is y. And we're going to use the equation Vy, which is a velocity in the y direction times time, plus a half gt squared, where g is negative 9.8 meters per second squared. And so what we're going to do is put in our numbers. So 13.5 meters per second times 1.38 seconds plus half negative 9.8 times 1.38 seconds squared. So once you put those numbers into our calculator, what we find is on the left side of the plus sign is 16.5 meters. On the right side here works out to 9.3, or not 9.3, but negative 9.3 meters. And then you calculate that, you get 9.3 meters. So when a ball is kicked at 30 degrees at 27 meters per second, the time the ball is in the air is 2.76 seconds. The distance the ball goes is 64.4 meters, and the height, the maximum height the ball goes, is 9.3 meters.